was 2.5 seconds, and what was the other one?
Wow.
Oh, 0.5 and 2.5. Okay. If the problem, and this is really important because you don't want to lose a point on this. If the problem asks for the interval that the height was at least, whatever it was, 26 feet, this is the interval. I don't want you to write 0.5, 2.5. I want you to write it as an interval notation, which is 0.5 is less than or equal to x is less than or equal to 2.5. Or you can write an interval notation using hard bracket, hard bracket. Okay, just remember to write the answer like that, an interval. Okay, let's go to number 19. Now, number 19 says that you have to solve the system algebraically. So turn your calculators off. I think that's the problem, right? This is a parabola, this is a line, we're going to solve it algebraically. We're going to have a parabola and a line. Is it going to hit once, is it going to hit twice, or is it going to hit 0? When it hits, if we're finding the solutions are points, coordinates, x, comma, y, so don't forget. The first thing you're going to do is you're going to get everything into the form y equals, correct? This one's already in the form y equals. I got to subtract the 10 onto the other side. So now I have the line, the linear function, written as y equal. Are you all good? Yes, Red, you good? Cuckoo? You with me? Okay, so now I'm going to set them equal to each other. So I have x squared minus x minus 4 equals negative 3x minus 10. This is a quadratic equation. I'm solving for x. So what do I do first? Allie, what do I do? Standard form. Very good. Everything's got to go onto one side, right, Rye? So negative 3x becomes a positive 3x. Put it on the other side. The negative 10 becomes a positive 10. Put it on the other side. This cancels out to 0, standard form, and you're left with x squared minus 5x plus 6. Yes? Factorable. The last number is positive, the signs are the same. They're both going to be negative. What multiplies to 6 and adds to 5? 3 times 2 is 6. Negative 3 and negative 2 is negative 5 when you add them. T times. Set each factor equal to 0 and solve. The roots are 3 and 2. Are those the solutions? No. No, 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 no. Those are the x of the solutions. They're the x of the solutions. Now I have to find the y's. Because remember, these are coordinates. Yes? You know, an x and a y number. So I'm going to plug the 3 in, but I think I'll use the line to do it because it's just easier. So I have, right here, I'm going to do negative 3 multiplied by 3 minus 10. So that's negative 19. And then to get the y here, I'm going to have negative 3, plug in a 2, minus 10, and what's that? Negative 16. And those are my solutions. Now, I can graph them and check my solutions. Make sure that those are the intersections. Okay? If I'm desperate and I can solve it algebraically on the regions, complete desperation, you have 5 minutes left till the bell's going to ring, solve it graphically. That's just desperation. All right, the last problem. This is the whamma jamma tomorrow. You're given a parabola. You have to find when it hits the max. Then you have to find the max height. Then you have to figure out an interval of time when it's at a certain height. There's a lot to do on this problem. If you understand number 20, you're going to be fine for the test because it has everything in it. All right, so let's see. A ball is tossed in the air, and the height is modeled by this equation, negative 16t squared plus 64t plus 4. The first part of the question, of course, the t is the seconds, the h of x is the height. All right, first question, how many seconds seconds after the ball is tossed will it reach its max? Time when it reaches max. Algebraically, T equals negative B over, right? Algebraically, that's when it hits its max. The axis of symmetry. That's when it hits its max. You get B over 2A. T equals the negative of the B, which is 64, over 2 times the A, which is negative 16. That's negative 64 over negative 32, which is 2 seconds. I'm going to do it algebraic, then I'll do it graphic, and you can do it whichever way you want on the test. Round to the nearest hundredth of a second. Round to the nearest hundredth of a second. How many seconds after the ball is tossed will it reach its max? It's 2 seconds, so I don't know why it wants you to round off. All right, part B. It says, after how many seconds does the ball return? Oh, I'm sorry. Part B. What is the ball's max height? Okay, finding max height. How do you do it algebraically? You take the time that it hits the max height, which I just figured out is 2, and I plug it in to my parabola. Negative 16, 2 squared plus 64, 2 plus 4. And I calculate that height. What is the maximum height at 2 seconds? The answer was? What was it? No one? 68 feet. Or yards or meters, I don't remember what it was. 68 feet. Okay, so far so good? So 268. 2 comma 68. Now I can double check it on the calculator. Let me just make sure I did this correctly. So, on my Y1, I'm going to type in negatives, the path of the ball. Negative 16x squared plus 64x. Does anyone have a question at this point on the algebra? My windows. What's a good window for time? 0 to 4 seconds? What do you think? A little more? 10? 6? What about the height of the ball? Start at the ground and go how up? 50 good? Oh no, I gotta go higher up. 70 was good? Higher up and less time. That's not bad, right? How would I spread this out? Less time, right? Instead of 8 seconds. You know, just if you wanted to look really pretty.
5, 4.
Oh, that's good. I like that one. Okay, so the next thing you're going to do, if you're doing it graphically, is you're going to write down on your piece of paper, if you decided to do this graphically, you're going to write down on your piece of paper what you put in for Y1, which of course was the parabola. Then you're going to do a little sketch, and you're going to copy the windows down on your paper, which I have up there, 0, 5, 1, blah, 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 blah. Copy the whole screen. And then you're going to write the calculator direction, how to find the max. Second trace number, I think it's 4. Is that correct? Left bound, right bound, enter. So graph, beautiful. Second trace, number 4 for max. Move your cursor left bound, press enter. Move your cursor right bound, press enter, and then press enter again. And you should have 2 and 68. Woohoo! And that's my answer. At 2 seconds, I hit 68 feet. All right. Any questions on the graphic or the algebraic? You're going to do that tomorrow. You're going to be okay with that? Ra, you good? Red? Okay, here we go. after how many seconds does the ball return to the ground? Okay, I want to know when you want to know when it hits the ground. Write this down to yourself if you have trouble with this. Your H is 0. You're going to do an intersection of your parabola and the ground. I want to know when it hits the ground. I can do an intersection. If you want to do it algebraically, you're going to take the parabola and set it equal to the ground, equals 0. Now, it's totally up to you how you want to handle this. This looks like a nice, easy factorable problem, though, doesn't it? Who did it algebraic? You all did it graphic? Okay, if you do it graphic, you're going to label this as your Y1, then you're going to label the ground. Then you're going to do second calc number 5. I keep on doing calc, second trace. That's what second trace makes calc. All right, so I'll do it that way. So my Y2 is ground. I draw my parabola, I copy my windows, I go back to my graph, I second trace intersect. I want to know when it hits the ground for the second time, so I go over to the second root, enter, 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 and it looks like 4 seconds. Is that correct? Round to the nearest hundredth. Oh, so it's 4.06. Oh, the nearest 10, so 4.0. 4.1. 4.1 seconds. All right, any questions? Finding the ground. The last section says, find the interval of time where it hit 25 feet. Okay, so, we'll do it graphically. Graphically. How is this graphic solution, like setting it up, how is it going to differ? Still going to keep this in as Y1, but now what? What do I have to do differently, Brock?
Y2 would be 25.
Yes. It was 25 feet? Good job, kiddo. And you're still going to find the points of intersection. So you all agree that this shouldn't take you a lot of time on the test to do these problems. All right? You should have enough time tomorrow to finish this test because a lot of it is very similar. Now I have 2 intervals of time. I have 2 intersections. I have to calculate them separately. Second trace, intersect, move the cursor to the first hit, enter, 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 and I get 4 point, I can't read that, 0.4, rounded to the nearest 10, 0.4. Second calc, does everyone agree? Just make sure you're getting 0.4.
Can you do it algebraically?
Yeah, do you want to do it algebraically? It's going to take you a lot more time. You might run out of time. And it's 3.6. So 0.4, 3.6. We want to know when it's at least that, which means it could be more. So at least could be more. So the interval is 0.4 to 3.6. Now, algebraically, we'll get back to you. You're going to, instead of the height being 0 for the ground, you're going to make the height 25. The problem is, it's not going to be factorable. So you're going to have to do dun 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 dun. You know you're going to have to use that quadratic because it comes out irrational. All right, questions on the first review packet? No? All right, second review packet. How many of you did it all? I made it shorter. Would you like the solutions? See if you got them all right? All right, I want you to put big marks, highlights, on the problems that you got incorrect. And those are the problems you're going to do over. If you did well on this review, you are going to get a very high score on tomorrow's test. There's going to be no need to worry. Do you believe me? My only concern with this test is you running out of time. That's my concern. So I really want you to manage your time tomorrow well. Don't do algebraic for every single problem. Use your calculator. It was made to finish in 40 minutes. That's my only concern with you little banana heads. All right, great. Let me see how many you got right and how many you got wrong. How you doing? Is it good, the batteries?
That's good.
And it's okay, it's clear?
Yeah, no, it's actually really
I always
good.
feel like
Yeah.
I'm like a little screwed on when I get it. I will load this
No
today
square.
on YouTube. You'll look for this review if you want to go through it again.
I didn't stop recording just so it wouldn't be 2 videos. So it's just one constant video. Is that good?
Yeah.
Okay. I'm tired. Is that good, or do you want me to make it 2 videos?
For the 2 reviews, you mean?
Yeah.
All right, we'll make it 2 reviews. Review number 1, review number 2.
All right, so I'll stop recording.
I think I should video you today. Not that I'm going to post it, but